Hi guys, in the previous lesson we have described how we can obtain the error dynamics especially in the estimator models, or the A and B can be estimated by using this error value with the minimization of itself. Okay, and so in this lesson we should use the adaptation algorithms. Okay, but I have some problem in here. Okay, I'm sorry. Okay, and so our title is that the adaptation algorithm. Okay, what is the adaptation algorithm? Adaptation algorithm means that our job or task is to find what the A hat dot value or B hat dot value, because if we don't have any dynamics with respect to time, and so we cannot converge the specific values of the A and B or the system parameters. Okay, and so in our error function we should describe any energy function in here, and so this energy function should be minimized by using by using these derivative terms. Okay, because in the previous lesson we have talked about it, what is the A1 dot value or the time derivative of the error value in here, and so our task is to minimize the I error and B error dynamics in here. Okay, and so if we have this kind of information in here, and so we should find the A hat dot and B hat dot in order to emulate or in order to obtain the future value of these things, or the past value or present value. Okay, and so I can write it down like the A hat 1 is equal to F1 depends on the Y or X U Y hat. With a similar case, the F2 is equal to the Y U Y hat. Okay, these are the basic algorithm, especially in depending on the Y U or Y hat. U can be calculated by using any microprocessor or the algorithms, and Y should be measurable, or in other way we should obtain this value by using measurement techniques. For example, the sensor or any other device should be given to these values. Okay, and so how can we obtain these values in here? Firstly, I split my screen into two parts like this one, and so I can say we should establish the stability rule in here. Okay, because it's important, and so if we define any Lyapunov function in here, like if we have the error values in here and V is an energy function like this one, we should add the 1 divided by 2 should be added in here in order to taking derivative gives us the 2 value, because the whole energies are in the form of the square, or in other sense should be positive at this moment, and so A1 square should be minimized in here. This is always the positive in this notation, and so also we define the new values. A error square plus B error square. Okay, what's the meaning of this? This means that A error equals to B hat minus B, and so if we are using the algorithm to minimize this term and this term, and so we can say that the A or real A is equal or converging to the what A hat. And so we can estimate the real values of the what A and B at this moment, okay? But we should give the other parameters in here, like this one. 1 divided by gamma. This is the learning rate of our algorithms, okay? And so we need to define these things because in the controller perspective we can calculate the u value with the specific coefficients of the proportional, integral or derivative terms, but in this case we should define itself in the equation form, okay? And so we need to add this learning rate in order to in order to converge our system parameters to the real value. And so the gamma is higher, and then we can have the fast convergence algorithms, okay? And so how can we minimize these things? We should be always positive, and we dot should be always equal or smaller than 0. These are the main term to obtain the stable or stability rule, okay? And so taking derivatives gives us to v dot is equal to the e1 dot plus 1 divided by gamma and a error dot, and plus 1 divided by gamma and b error hat and error hat dot, okay? These are the objective function which is given with the v, and so these are minimization function body. And so we have the e1 dot. In the previous lesson we have created these things, and so we can rewrite the whole equation like this one: e1 times minus am e1 plus a error hat x minus b error hat u, okay? And also we should add the 1 divided by gamma a error hat dot plus 1 divided by gamma b error hat dot, okay? And so how we can use this utilization in here like this one? Our task is to find the a hat dot and b hat dot value. Okay. And so I use the imagination of they recollect the whole equation given in here, okay? And so I can recollect these terms like this one. V that is equal to what? Firstly, I can split the am times e1 square, because it's coming from this equation in here like this one. And so I can collect the whole terms, the error hat in here, a error hat times, which is coming from the x times e1 in here, coming from these things. And so in otherwise we have at the right hand of this equation we have a error hat in here plus 1 gamma a error hat dot, okay? And so we can also collect the b hat or error hat dot in here like this one. This is equal to the e1 times u, but we should add the minus 1 in here because this is the subtract operation in here, and plus 1 divided by gamma and b error hat dot, okay? And so how can we use this equation in order to stabilize the system? Firstly, we should say that this is always goes to 0, okay? This is stable. But how can we suppress the other terms in here? Firstly, a hat or error hat b and b error hat is some specific constant in here, which means that they cannot be 0 because the system parameters are consisted of these two things. And so in order to minimize the R equation, these terms should be equal to the 0. Okay? Because if these two things are 0, and this system is always stable. And luckily we have the derivative terms of the what A error hat and B error hat in here. This is perfect for us. Okay? And so we have two conditions in here, like this one. If we have the, or if I eliminate these terms in here, and so we can write down 1 divided by gamma in here, like this one, A error hat times plus X E1 is equal to the 0. And also we can say that 1 divided by gamma times B error hat minus U times E1 is equal to 0. And so easily we can write it down, or write at the hand of this equation. And so A error hat is equal to the what? The minus gamma times X times E1. And so B error hat is equal to the what? Gamma times U times E1. This is the R adaptation rule of the equation. But you should remember that the A hat is equal to the what? Error hat is equal to the A hat minus A. And so B error hat is equal to the B hat minus B. And so if I expand this equation with this notation, and so this whole equation is given from in this form, right? This one, A hat dot minus A at A dot is equal to the what? Minus gamma X E1. And B hat times minus B dot is equal to the what? To gamma times U times E1. And so how can we obtain this A dot and B dot value? This unknown. And so it's also derivatives are unknown parameters, or the dynamics. And so with the basic assumption of A and B, we should say that A and B should be constant in here. Okay? Or slowly change in time. Okay? And so these terms eliminate in here, and so in the last form we can reach out to what? The A hat dot is equal to the what? Minus gamma times X times E1, and B hat times equal to the gamma times U times E1. This is our adaptation rule to what? To minimize the errors in what? E1 system characteristics, A error hat and B error hat. And so if we are gonna use this equation in the form of the update values on the what? The A hat and B hat, we can reach the estimated value of the system parameters, or in other way, A and B value. Okay? And so in the next lesson we will talk about how we can create the MATLAB Simulink model or simulation model in order to what? In order to prove that these adaptation rules and error terms are okay in our algorithms. Okay?